Hey folks, so this is your lesson video for section 11.4. If you have not watched the notes video yet, please just stop this video and go back and watch the notes video first so that you can get a little bit more understanding before you just dive right on in. So you notice that the first thing that we're looking at here is a picture that we saw almost the exact same thing back in section 11.3. The difference here is that I've changed my notation a little bit. So you can see that my notation now is the complex number a plus bi. Yes, that's the same a plus bi that we worked with back in Math 110. And so what we can do is we can take our a plus bi and we can actually write it and graph it like we do a vector. Now, a plus bi, as I mentioned in the notes video, a plus bi is considered your rectangular form. The word rectangular is always going to refer back to the legs. Remember that in section 11.3, we divided our brain into two sections. We had the legs portion and we had the r's and thetas portion. So anytime you see the word rectangular, that's always going to mean legs. In the same way, anytime you see the word polar, polar is always going to mean r's and thetas. Okay, so rectangular refers to legs, polar refers to r's and thetas. Now, what we can do here is we can take our rectangular form, our leg form, and we can turn it into polar form, into r's and thetas, simply by using the equations that we used back in section 11.3. You remember these guys. So let's use our equations and let's plug and chug into our rectangular form and turn everything into r's and thetas. So the first thing I'll do is that I'm going to take my a out and replace it with r cosine theta. Then I'll take my b out and replace it with r sine theta. Don't forget you still have an I tacked on there. Now, when I look at these two terms, I can see that they both have an r in them as a GCF, so I'm going to factor out the r. I'll be left then with cosine theta plus cosine theta plus sine of theta, and that sine of theta is being multiplied by I. You can see that I moved the I into the front just so that it's a little less confusing. Okay, so this is my polar form then, r times the quantity cosine theta plus I sine theta. Let's just jump right on into example number 1. It says to write the number in a rectangular form. Once again, back in section 11.3, I kept asking you the same two questions. What do you have? What do you want? When you look at example 1, you have r's and thetas. What do you want? That's in the directions. So the directions just simply say to find the legs, the rectangular form. So one nice thing about this, yes, I could always go back and use my two equations like what we used back in section 11.3, but now it gets even easier. So let's come down to example number 1. All I have to do is simply simplify. Simply simplify. Figure out what is the cosine of 60. Use your unit circle. Figure out what is the sine of 60. Use your unit circle. Plug and chug. All right, so we have our 4, that's our radius, times the quantity cosine 60. Well, let's go over to our unit circle and let's draw this first of all. Cosine of 60 is going to be a half. What's the sine of 60? Root 3 over 2. Don't forget you've got an I there. Now let's take our 4 and let's distribute. So 4 times a half is 2. 4 times the square root of 3 over 2 is going to reduce to a 2 root 3. Don't forget you have an I there. You'll notice that I put the I in front of the square root. If you get a little bit sloppy and you put the I after the square root, sometimes you might not be able to tell if the I is under or not under the square root. And in that particular case, it would get marked wrong on your paper. Now let's look at example number 2. Example number 2 has a different notation. So let's go back up to this polar form. This polar form can also be written r cis. Now that stands for cosine plus I sine theta. So r cis theta is the exact same thing. These two are identical to each other. One's just a shortened form. And so that's what you see on number 2, 6 times the cosine of my theta, 3 pi over 4, plus I sine of my theta, 3 pi over 4. And I'll go ahead and just show you that in the long way to write that. So again, let's simply simplify. We'll use our unit circle to map out where 3 pi over 4 is. We know that the cosine of 3 pi over 4 is negative root 2 over 2. The sine of 3 pi over 4 is positive root 2 over 2, and I also have that I in there. My radius out front is 6. Distribute. And when you distribute and reduce your fractions, you're going to get negative 3 root 2 plus 3i root 2. All right, let's head into example number 3. Okay, what are the two questions again? What do you have? What do you want? Okay, so we look at what we have. We have legs. What do we want? Oh dear, they're trying to trick us. It says trigonometric form. Trigonometric form is code for polar form. So when you run into that in MyLab Math, make sure that you understand trigonometric form simply means polar form, r's and thetas. Now, do you remember back in section 11.3 how I told you anytime you have legs, draw a picture? And so that's where we are right now. We've got legs. Let's go draw ourselves a picture. And so I'm drawing a picture in the second quadrant. And you'll notice that I've already found my radius just by using the Pythagorean theorem. Okay, so my radius is going to be 4 using the Pythagorean theorem. My theta. Now let's walk through this like I walked through it in the last section, section 11.3. So once again, look at your picture and tell me, what two numbers are the prettiest numbers? You would agree with me that the negative 2 and the 4 are the prettiest numbers. And not only that, these are the adjacent and the hypotenuse. So then we would say that the cosine of our angle is equal to the adjacent divided by the hypotenuse. Well, the adjacent divided by the hypotenuse will reduce to cosine theta equals negative 1/2. And so I'm going to ask myself, in this picture, where in the second quadrant is cosine equal to a negative 1/2? And you'll also notice that I've been given a restriction, and my restriction has to be in degrees from 0 to 360. So my theta then is going to be at 120 degrees. Now, I found my r's and my thetas, but I haven't put it into polar form yet. So we need to use our proper format. So that's from the first page. And so our radius is 4 times the cosine of 120 plus I sine 120. That's going to be my polar form. Look at number 4. So once again, ask yourself, what do you have? What do you want? What do you have? You have legs. What do you want? Trigonometric form. That's the same thing as polar form. Same thing as r's and thetas. Anytime you have legs, you want to draw a picture. So let's go draw the picture first. Negative 5 minus 5i. This is going to be in the third quadrant. Do the Pythagorean theorem to find your missing radius. And you'll find immediately that your radius is 5 root 2. Again, use the Pythagorean theorem on that. Now, on this case, notice that my sine and my cosine are exactly the same thing because the adjacent over the hypotenuse is the same as the opposite over the hypotenuse. Both of them are going to be negative 5 over 5 root 2. Reduce your fractions there, and you're going to end up with negative 1 over root 2, and negative 1 over root 2 is the same thing as negative root 2 over 2. So then you ask yourself, in the third quadrant, what is your theta that's smack dab in the middle? Be careful to follow your directions. You could say that that's 225 degrees, but we're working in radians on this question. So make sure that you name it with a radian, which is going to be 5 pi over 4. Now, this is great. I do have my r and I have my theta, but I have not written it in polar form yet. So that's the last thing I'm going to do is write it in polar form, which is going to be r cis theta. 5 root 2 is my r, cis my theta, which was 5 pi over 4. Now let's slide over to example number 5. Example number 5 is one of those that it's so easy that students miss it. So again, you ask, what do you have? What do you want? What do you have? You have a leg. Only one. What do you want? We already know we want our r's and thetas. Anytime you have legs, you want to draw your picture. Okay, so I draw my picture and I'm going to be up on the y-axis. If I were to draw a circle here, what would my radius be? Well, my radius would be 5. What is my theta at this spot? Well, my theta in radians is pi over 2. So then what's my polar form? R cis theta, 5 cis pi over 2. Now, in order to multiply two polar numbers together, I'm going to be using this equation right here. Okay? So, and you'll also see that I've given you, here's my first polar form, and here's my second polar form. And in the notes video, I would have talked about how we are multiplying our r's, we are adding our thetas. So let's just jump into an example here. Okay, please make sure that you read the directions on these about how you should answer your final answer. So our directions say that we should find the product, so we're going to be multiplying. We should find our product, though, in rectangular form. So our final answer needs to be in rectangular form, and you remember this means legs. Okay, so the first thing that I'll do is I'm going to use my equation up here. Make sure you have that handy. I can't show them both at the same time. I'm going to be multiplying my radii, and then I'm going to be adding my thetas. So there's a cosine of my 2 thetas added, plus I sine of my 2 thetas added. Clean that up, so we have 20 for the new radius. When I add my thetas, I'm going to get 150. Now, this answer right here, this guy is the polar form. If my directions told me to give my answer in polar form, I would be finished right now. But it didn't say or didn't ask for polar form, it asked for rectangular form. And so I need to take this a step further. Remember, if you have polar and you want rectangular, simply simplify. So I'm going to first draw a picture of where my 150 degrees is. And my cosine at that spot is negative root 3 over 2. My sine is 1/2. Bring down your radius. Go ahead and distribute your radius and simplify. And so now my rectangular form is going to be negative 10 root 3 plus 10i. So those are the legs of this particular vector. Example number 7 is almost exactly the same thing. The difference is that I use the shortened version and I'm in radians. So let's go ahead then. We'll multiply our r's. And then we will add our thetas. So I'm just going to continue to use the shortened version here. And so I'll add my thetas. Now you can see that I've already 2 pi over 3 plus negative pi over 6. I've already gotten a common denominator here. And so when I add my thetas, I'll have 3 pi over 6. Of course, I won't leave it like that. I'll reduce that to pi over 2. Now, again, if my directions had said polar form, I would be finished. But since it says rectangular form, I need to simply simplify. So we'll go ahead then. We know that pi over 2 is up at the top of the circle. And so my cosine value is 0. My sine value is 1. Take your radius and distribute so that you have 0 plus 30i. Dividing polar numbers is very, very, very similar to multiplying. So you'll notice that now I'm dividing my radii and I'm subtracting my thetas. That's really the only difference. So let's jump right on into the next example, example number 8. So the first thing that I want to do is I want to divide my radii. So 16 divided by 8 is 2. And then I'm going to subtract my thetas. We'll clean that up so that I get 240 for my theta. Once again, notice that in the directions we're asked for rectangular form. If we were asked for polar form, I'd be finished. But let's simply simplify, so I'll need the unit circle for that. 240 degrees, 240 degrees is going to be this guy down here. All right, so we have our radius. The cosine at 240 is going to be -1/2. The sine at 240 is going to be -√3/2. Go ahead and distribute your radius, and you'll get a -1 minus an I√3 once you reduce your fractions. For example number 9, same concept, only I'm using the shortened version, and I'm also in radian mode again. So once again, let's divide our radii, subtract your thetas. 5π/6 minus π/6 is 4π/6. Go ahead and reduce your theta. If you were asked for polar form, you would be finished. But you're asked for rectangular form, so simply simplify. We'll go ahead and get our unit circle out. The cosine value at that spot is -1/2. The sine is √3/2. Go ahead and distribute your 12, and you'll get a -6 plus 6i√3 once you reduce your fractions.